Hello, I'm a PhD student at Chalmers University of Technology in Sweden. In this video, you will see a broad picture of my PhD project, which is concerned with developing cryogenic low noise transistors. Let's see how they work and where they are used. So, cryogenic low noise transistors are one of the most important electronic components for equipment used for exploring the universe. For example, it was used in equipment on satellites that took the first picture of a black hole, something scientists have previously believed to be impossible, but have now opened up the possibility of confirming details of Einstein's general theory of relativity. Also, cryogenic low noise transistors are used in equipment used to detect and investigate planets outside of our solar system. Among other things, scientists are looking for possible habitable environment. Now I will explain how the data from satellites in space is processed. This picture shows the telescope with several antennas located in Chile, operated by NASA. Each antenna receives a signal with a power of 10 to the minus 20 watt. Comparing the power for the light bulb, it is an extremely weak signal since it is transmitted from so far away. These weak signals are focused to the middle of the antenna to enhance the detection efficiency. The signal then goes through the receiver. It shows a receiver, and at the front part of the receiver, the signal is processed in a low noise amplifier. Now you might wonder what the low noise amplifier is for. The amplifiers usually amplify the input signal around 10,000 times. When we look inside this amplifier, we see a low noise transistor, which is the key component in amplifying the weak signal. The more amplification the transistor can do, the better it is, since the signal is very, very weak. At the same time, noise, which is unavoidable in almost all electronic components, should be very, very low. Otherwise, output signal is disturbed by noise. So the large noise will destroy reading out the output signal. Now, what is a transistor and how do we reduce the noise? I will explain the simple concept of the transistor and noise. The transistor consists of three terminals: the source, drain, and gate terminals. Electrons in the tunnel travel from the source to the drain to generate a signal. Let's look at the tap. The water going through the source to the drain. Here the water is like electrons in the transistor. The water flow is the signal that the transistor generates. The water flow is controlled by the tap node, which work like the gate in the transistor. The small change of the input gate contribute a large difference to the output drain. So when the output is stronger than the input signal, we say the signal is amplified. This is how the transistor amplify the signal, and we call it is amplifier. Then, what are the causes of noise in transistors? Any fluctuation or disturbance of the electrons can cause noise. Resistance, which disturb the flow of electron, is one important noise source. Also, high temperature increase the noise since it increases electron energy, which make the movement of electrons more random. In addition, if there are lots of electrons in the channel, they will collide with each other more, which can result in increased noise. Then how can we reduce the noise? First, we should reduce the resistance by smart choices of less resistive material and process engineering. Second, we should ensure a low ambient temperature. The research I conduct is mostly done at cryogenic temperature, which means temperature between 1 and 10 Kelvin. In other words, very close to the absolute zero. Lastly, in order to reduce electron collisions, the transistor should be able to operate with a small number of electrons, but still with high amplification efficiency. In order to achieve this, electron must have to move faster, which is quite challenging. So lots of researchers are working on this. Here at Chalmers University, I participate in the design, fabrication, and characterization of low-noise transistors. We collaborate closely with industry. The main collaborator is the company Low Noise Factory in Sweden, which design, assembles, and tests low-noise amplifiers. The end product are being used by several important companies and research organizations. Here we see our important role for enabling advances in radio astronomy and fundamental physics. Thank you for watching, and in the future, please don't forget the role of the low noise transistors when you hear any news about the universe. Have a nice day, and until next time, keep that noise down. Bye bye.